Hello, thanks for joining me. Today we're looking at a PD9000 multivariable controller set up for some of the new advanced pump control features. We're looking at a pump down pump station where we have a continuous level sensor, 3 floats, and a couple of digital inputs for alarms. The station is set up to do pump alternation, alternating between 2 pumps, with some lead lag capabilities as well. There are float backups, a low float, a mid float, and a high float. And then we're looking at pump bearing temperature and a leak seal, as well as motor ramps. Additionally, we're tracking the maximum amount of time when a pump has not run, and then we're also tracking the number of pump cycles per hour. So all of that has been set up and is configured here, and we'll just go through and explore that a little bit. So this is the home screen. We're looking at the pump station. We have the level shown in percent, 0 to 100%. You could scale that for feet or inches or gallons or anything else you wanted. We have a high level alarm on at 80%. We're showing pump 1 and pump 2 status and runtime. And then we have a low level on at 5%. Additionally, we have this bar graph giving an indication of where the level is at, and then the high and low level alarm set point indicators. So normal operation, we will see the level rise up, and when we get to 50%, which is the first set point, we will see pump number 1 turn on after a slight delay. So at the on point there's a slight delay, and then the pump turns on. That will drain down to the reset point, which is at 10%, and there'll be a slight delay for that as well. So that pump turned off. Now the next time we get to the same 50% set point, we will see pump number 2 turn on. Again, after a delay, pump number 2 turns on, and you can see the runtime is starting to accumulate as well. And then that pump turns off at the same 10% set point. So that's normal operation. The pumps will just alternate back and forth at that 50-10 range. If the first pump is unable to keep up, so the level reaches 50%, but the level continues to rise, then we will see the second pump turn on at 60%. So we have both pumps on at 60%. Those will be able to drain down, and we'll see the last pump to turn on will turn off at 20%. The first pump to turn on is the first pump to turn off. So pump 1 turned on first, going up, so now it turns off first at 20% going down. And then we will see pump number 2 turn off at that same 10% point. So standard pump alternation with a little bit of lead lag as well. 2 alarms built in. We have the low alarm and a high alarm. If either of those occur, if a low alarm occurs, we will see the channel turn red, the alarm status will change to on, it will blink and flash, as well as the sump level. Also, you get this alert indicator showing up. That stays on, so you have a low level, but then it corrects itself before an operator has a chance to arrive. even though now the condition has cleared and we're no longer in a low level situation, that will stay on until an operator comes by. They can push that button. They will see alarm 2 low level. They can acknowledge that, and now it will go away and reset. So everybody is aware of what happened. So that's the general operation overview of how the controller works. The next screen we have is a detailed view of pump number 1. Here we still show the pump 1 status, which is off right now. The runtime, also the cycle count. We have the amps, which are 0 because again the pump is off. And then we have the pump HOA status. There's an onboard HOA switch with these function keys, and right now it is set to auto. These F1, 2, 3 function keys here function as an HOA switch and are labeled as such. This F1 button is the hand, F2 is off, and F3 is auto. So if I push F1, the pump goes into on mode. It shows it's in hand, and then you get the yellow alert to indicate that as well. You see the runtime is accumulating and cycle count increased by 1. If I want to turn it off, I push H2 or F2. That turns it off. And then if I want to go back to auto, I press F3, goes to auto, and that clears the alert. So that's how that function works. And then we have the same thing on the next screen for pump number 2. So pump 2 status, pump 2 amps, and the same HOA function. The next screen we have shows the floats. So we have a low float, a mid float, and a high float. And then we're also monitoring a sensor fail alarm if there's a signal break on the 4 to 20 milliamp input. And then we have pump 1 and pump 2 status as well. So right now the low float is on, the level is normal. Usually these backup floats will be used if there is an issue with the sensors. So we'll simulate a sensor fail alarm. We can disconnect the input. We get an alert, and then the sensor fail alarm turns on. So that alarm is on, and now we would essentially be running off the floats. So your 4 to 20 input is no good. The level keeps rising. Mid float will turn on first, and then we will see one of the pumps turn on based on that. So mid float, and after there'll be a delay. So once the float closes, there'll be a slight delay, and then the pump turn on. So slight delay, and pump 2 is the one that turned on. That will continue pumping. The mid float will turn off soon, but pump 2 stays on until the low float turns off. And so we'll turn the low float off. Pump 2 will turn on again after a brief delay. So pump 2 turns off. So that's sort of a normal pump cycle. We can see it happen again. The level rises, the low float on first. Once we get to the mid float again the second time, this time it'll be pump 1. So we still have that alternation even when working on floats. And then we'll see that one turn off again after a delay as well. So they continue operating. The next time mid float on, we'll see pump 2 on. Now if the level continue rising, we get the high float on, and we will have both pumps on at the high float. Those drain down, high float off, mid float off, both pumps still on until we get to the low float. And now there should be a staggered off. We should see one of the pumps turn off, and then after a brief delay, the other one will turn off. They won't both all turn off at the same time. So we had pump 1 turn off first, and then pump 2 turned off after a delay. And those delays are configurable. Right now they're set up for 1 second and 2 seconds, but they can be configured by the user for anything that needs to happen. So we have a sensor fail alarm. If an operator arrives and sees that, they can click on the alert button. It will give them an indication that they have a low level alarm, they have their sensor fail, and that is also a non-critical pump alarm. So we saw that the pumps were still able to operate even though that alarm had occurred. If this was a critical alarm, which we'll see in a little bit, the pumps would not operate. So we can acknowledge all of those. And now it still shows up as an acknowledged alarm because the condition still exists. Now we will reconnect the sensor, and then that will clear, and so it's no longer in place. It's showing me a low alarm again, and if I raise that level up a little bit and then acknowledge it, that will clear, and now everything is all back to normal. Here we have a screen that shows all the alarms associated with pump number 1. On the left side we have the non-critical alarms. These are alarms, if that occurs, we want to continue allowing the pump to operate. Whereas on the right side we have critical alarms. If any of those alarms occur, we want to shut the pump down and prevent it from turning on. So under non-critical, we have high amps for monitoring the current draw. If that has exceeded our threshold, we want to be aware of it, but we're not going to stop the pump. And then we have maximum starts per hour. If we are starting the pump an excessively high amount of times, again, we want to be aware of that, but we do want to allow it to continue operating if that happens. On the critical side, we have over temp alarm and seal fail. So if the bearing temperature or the internal temperature of the motor of the pump starts to overheat, we want to shut that pump down before any further damage occurs, as well as the seal fail. If we start to get a break between the wet and dry side of things, we want to be aware of that and service that as soon as possible. So we will now simulate a critical alarm. We'll see that come in as a digital input, and once that status occurs, then we will be unable to start pump number 1. So we get a digital input. This is an over temperature alarm, so we're simulating a high temperature condition on that pump. We see that status alert on the screen as well as an alert down at the bottom. And so now that this alarm is on, pump number 1 will not turn on. So we'll navigate to the main pump control screen and see that in action. So now we're back at the main pump control screen. Our level is at 11%. And once we get to that same 50%, we'll not see pump number 1 turn on. It should be only pump number 2. So the level comes up and we get to 50%. Pump number 2 turns on, drains down, and shuts off at 10%. And now the next time we get to that same 50%, previously it alternated and pump number 1 would turn on, but now it's going to go back to pump number 2 again because pump 1 is in critical condition. So it's just going to stay on pump number 2 and pump 1 won't turn on. Even if the level continues to rise, and even if we get to that 60% set point where now normally both pumps would be on, even so pump 1 is not turning on because it's in that critical condition. So it won't turn on until that condition is cleared. So we come down and we turn pump number 2 off. And now we're sort of in normal operation mode. So if a operator arrives, they see the alert, they can click on that, they see that pump number 1 is over temp, and they want to acknowledge that. We've exceeded our number of starts per hour as well. They can acknowledge that. And then pump 1 is in critical condition, and then pump 2 is a non-critical from the starts per hour. But now we're just seeing the critical alarms, and no matter how they acknowledge them, they won't clear because that alarm condition is still present. If the alarm condition clears, now they can acknowledge that, and they should clear. We'll notice though that pump number 1 still will not turn on under this condition. It'll still only be pump number 2 at the 50%, and then also even above 60%, pump number 1 still doesn't turn on. What we have to do is go to that HOA screen, and after a critical alarm has occurred, the pump defaults to the off position on the HOA, so we'll need to put it back into auto mode, at which point it will turn on because it's called to be on, and then the level will continue draining down. So just an overview there of how critical alarms function on this device. Here we have the max off time alarm screen. So this is monitoring how long it has been since either pump has run. In certain low flow stations, there may be instances where liquid will sit for a long time before a pump is called to pump it away. So we might want to set up a timer so that regardless of the level, if a certain amount of time is exceeded, we want to turn the pump on and just drain it down to the reset point and get rid of as much as we can. So we have set that up for 12 hours. So this is a 12-hour timer. So if no pump runs in 12 hours, this alarm will turn on. That's easily configurable for any amount of time that is desired. And you can see right now it's not moving because pump number 1 is on. So pump number 1 is on right now. And we'll turn it off in a minute, and we'll see this timer reset and start counting down from 12 hours. So pump 1 turned off, it reset to 12 hours, and now it's counting down. So as soon as it hits 12 hours, we'll get this alarm to turn on. Then, so long as the low float is on, the next pump will turn on and drain down until the low float turns off. So it's all based on this timer and the low float. If the level is below the low float value, then it will not pump because that's a low level condition, and we wouldn't want to do that. So handy feature to have for some of those low flow stations. This screen is showing the maximum starts per hour alarm. A user may want to set a limit on how many times the pump will start in each hour, or they may want to get visibility if it is starting an excessively high amount of times, so that they could adjust their set points for more economical pump usage. We're showing pump 1 and pump 2 status along with the runtime and cycle count just for reference. This is the pump starts, number of pump starts this hour that have occurred this hour, and then we have the pump starts that occurred in the previous hour, and then we also have the alarm itself. Maximum pump starts per hour is off right now, and the set point is set at 10 starts. So right now we're at 9 starts for both pumps this hour. If either of those pumps start again, we will see that alarm occur because it is at the set point value is at 10. So we'll engage a float, and we saw pump 1 turn on. So now this alarm has turned on, and we are at 10 starts per hour. The level continues rising, and we also see pump number 2 turn on. That unit will go into alarm as well. If they're able to pump down and then shut off, these alarms stay on because we've still exceeded the number of starts this hour. This alarm is set up as a non-critical alarm, so even if this alarm occurs, the pumps will still run. So if they are called to run again in this same hour, we will see pump 1 or pump 2 and pump 1 still turning on, and that count continuing to increase because this is a non-critical alarm. If this alarm occurs, we have this screen that is blinking, and then we also have the alert. We can navigate to that screen. We see pump 1 max starts per hour, pump 2 max starts per hour, and then pump 1 and 2 are in non-critical status. We can acknowledge the starts per hour as well as the non-critical nature alarms. We still get that visualization that they exceeded their number of starts, and the previous hour's starts will be kept track of as well. So, handy feature to have to dial in the setup of a station. The next thing to look at is the configuration of the device. There are a handful of input scaling ranges and engineering units, pump set points and alarm set points that a user may want to adjust for their specific application. The way to do that is to press the menu button and then click the setup button in the right side. And usually most of the information is under channels, so you navigate to the right and select the channel that you want to adjust. Sump level might be one. This brings up your screen for that. Click the edit button, scroll down. You can change the engineering units from percent to gallons or feet or anything else. Keep scrolling, and you can change the 4 to 20 milliamp range for anything that you need to do. So very easy to change and adjust that. Continuing on, pump 1 amps and pump 2 amps are the same way to adjust those. The next one would be your lead pump auto and your lag pump auto. You can step into those channels, edit that, and scroll down, and you have your on and off points. Right now they're 50% and 10%. If you change the units of the level to feet, those units would carry over, and those set points can be easily adjusted there, as well as your on delay and off delay. Right now set for 1 second on that, but that could be easily adjusted there as well. And the same thing for the lag pump. This is set up to be 60 and 20 and have a 2-second delay, but those parameters can be easily changed on that screen as well. So those are all the items that need to get adjusted under channels. Finally, you might want to adjust a timer, the max off timer. This is set up for 12 hours, but maybe you want a different value. You just click the edit button, scroll down to the 12-hour setting right there, and you can edit that for whatever time you may need. Next would be the alarms. You have a list of your high level alarm, low level alarms. Those are again just set points. You jump into one of those, edit that, and scroll down to your set point, on at 80%, off at 60% for a high level. Maybe you want to change that to a different range. Fairly easy to do so. Low level works the same way. Pump 1 high amps, pump 2 high amps also work the same way. Overtemp, seal, fail are just related to a digital input, so nothing really to do there. Then you have your max starts per hour. Same thing, you're just adjusting a set point. Right now is set up to 10, but you may want to increase or decrease that. And then the pump 1 and pump 2 critical and non-critical sections are easy to adjust as well. So pump 1 critical, navigate into that, edit that, and you can select what you want to consider a critical alarm. Right now we have overtemp and seal fail, but maybe you want to add in something. You can insert and then select maybe you want to consider high amps a critical alarm, you can just add that in as a critical alarm. So very easy to adjust that. And then the non-critical operation works the same way. You would just add or remove alarms that you want to consider critical or non-critical. So those are really the only parameters that you would have to adjust. Then you could go down to screens, and if you wanted to adjust what showed up on which screen, it's pretty easy to do that as well. So certainly designed to be very user-friendly and easy to adjust for anybody with experience with these kind of devices.